So one of the topics that everybody seems to be talking about lately is AI. I was at CES in Las Vegas earlier this year, and one of the most interesting observations is that pretty much anybody who made anything just made whatever the thing was, but they made an AI-enabled version of that thing and then put it out there, which it turns out is exactly the same thing as what the thing was in the first place. So there's a lot of hype around AI, but you know, imagine if we could actually get AI to be useful. That's what our next speaker is going to talk about. Please welcome Dan Jenkins from AdTheorent.
All right. Hi, everyone. My name is Dan Jenkins. I lead the data science team at AdTheorent. So today I'm going to talk about artificial intelligence demystified. Basically, just give a quick high-level overview of how artificial intelligence, machine learning, how these technologies work, and how they're applied in the advertising space. So AdTheorent, we've been around since 2011. We've been applying machine learning to the digital advertising space since the beginning. As you can see here, we've been recognized several times recently for our technology and our success in the digital advertising space. So artificial intelligence, as was mentioned, kind of a buzzword. What does it really mean? The reality is it's a very broad term. It can be applied to pretty much any time you have a machine, a computer, demonstrating the problem-solving ability, the decision-making ability that you'd usually rely on a human for. So it covers a wide variety of technologies, everything from what you'd traditionally think of as robots to the image recognition on your cell phone. But for today, we're going to focus primarily on machine learning, which is kind of the most important piece of AI in the advertising space. You can kind of think of machine learning as the brain of AI. So machine learning, it's a type of AI focused on developing systems that can adapt and change when exposed to new data. So basically, you allow the machine learning system to make decisions. It gets feedback on whether those decisions are successful or not. And then as it gets more and more feedback, it's able to adapt and improve its ability to make future decisions. So the key question when talking about AI machine learning is what problem is it solving for me? In the realm of advertising, we're mainly focused on the problem of ad targeting, basically deciding, do we want to put an ad in front of this person at this time? The traditional way to approach this problem, we have a user on a website, in this case, New York Times. When the user gets that site, basically makes a call to the ad server and says, do you want to place an ad in front of this person? Traditionally, those decisions would be made by a series of if-then rules. So if the user has been to the client's website before, yes, let's serve them an ad. That would be an example of retargeting. You also have things like geo-targeting, audience targeting, and you can combine these rules in a wide variety of ways. But at the end of the day, you're basically relying on a combination of intuition and trial and error to decide which rules should we be using. The goal when we introduce machine learning to the system, the goal is to really skip straight to our underlying campaign goals, the underlying business need that we're trying to fulfill. So for the moment, we'll say that our goal is for a user to see this ad and then complete some action. We'll call it conversion. So once we have machine learning, instead of these simple if-then rules, what happens is when there's an opportunity to serve an ad, the ad server makes a call to the machine learning system and basically says, if I were to serve this ad to this person at this time, how likely are they to convert? Once we have that probability, it makes a much easier decision of whether to serve the ad or not. If they have a very high likelihood of converting, we're going to want to serve that ad. And that probability also may impact how much we're willing to pay for that ad space. But the key point is by cutting straight to that probability of conversion, we can really rely on a data-driven approach as opposed to just trial and error and intuition. However, in order for this to be successful, we need to make sure that we're asking the system the right question. So far, we're just saying, what is the probability the user will convert if we display this ad? But what does that mean? It may mean view a video to the completion. It may mean visit a location, the client's retail store. It may mean make a purchase. That purchase may happen online. It may happen in person. But the key point here is none of these AI or machine learning systems can tell you what the goal of your campaign should be. That really depends on what your clients are looking for, the underlying business need. These algorithms, they don't understand what a consumer is, what an ad is, what a conversion is. It's really just statistics, math applied to large data sets. So we have to make sure that we've defined the right problem for these systems to solve. Once we've defined our question, it has to be translated into a language the computer can understand, which is going to be math. This is just kind of a very simple, made-up equation. And I won't go into too much detail because we don't have too much time today. But the basic idea, we're asking the computer to find a formula or an equation that it can use to calculate this probability of conversion. And the way it does that, it basically, it has a space of possible equations. Literally infinitely many equations. And most of those equations are going to be wrong. But what it does is it scans through the database. It looks at a record of every impression that was served, whether it converted or not. And then among all the possible equations that it could use to predict probabilities, it's selecting the equation that best fits that particular data set for that campaign and that conversion goal. Once we have that, we can predict the probability of conversion for future ads. And if we have a nice high probability, we want to serve the ad. And if not, obviously we won't. Another way to think about the statistical optimization I just mentioned that's maybe a little more intuitive is visually. So if we look at this plot here, we can imagine that each point represents an impression that was served for the campaign. And maybe the horizontal axis represents time of day. And the vertical axis represents an audience score. So just by looking at this, we can see some kind of obvious trends in the data, where the blue points, the successful conversions, tend to be up and right. The red points tend to be down and left. And really, at the end of the day, that's all of these AI algorithms are doing, is trying to identify these patterns. We see this black line running down the middle. That's basically the point where the algorithm is equally likely to believe it's a red dot or a blue dot. So along that line, the algorithm would predict there's a 50% chance of probability. If we had a new opportunity to serve an impression that was way up and right, it might predict there's a 95% chance of probability. If we have an opportunity to serve an ad that lies just above this black line, maybe there's a 54% chance of probability. However, we may get unlucky. Maybe that ad does not convert. Now we have a new data point introduced to this plot, a new red point sitting just above that black line. And that's where the learning and machine learning comes in, is basically the algorithm is able to adapt to that new information, recognize that new pattern in the data. And what we'd see visually is just that, that black line would just shift a little bit to account for that new data point. And then that would be the pattern that it would use to make future predictions. So we can look at the same thing in 3 dimensions. Maybe now we have the 3 axes are time of day, an audience score, and a publisher score. But the intuition is exactly the same. The algorithm is trying to identify these patterns, look for ways to separate the successful ads from the unsuccessful ads, and use those patterns to make predictions for future ads. In a real example, we might have 5, 10, 20, 100 dimensions. We can't draw these nice pictures there, but the underlying intuition, the underlying math, the underlying technology is exactly the same. All right, so the key takeaway point of today's discussion is humans and computers, they're going to work together. The computers are not out here to take all our jobs away, eliminate the human role in advertising. The starting point is we need to make sure that we're asking the right questions of these systems. They can't tell us what our goals should be. They can't tell us what question we should be asking. Second, we want to make sure that we're monitoring what these systems are doing and that we're learning from the patterns that these systems identify. For example, if the machine learning system says that females in Boston are highly likely to convert, that may be useful information that we were not aware of, and it may impact how we run future campaigns. And as a data scientist, these new patterns may give you sort of new ways to look at the data and lead to new data points that you may explore for future modeling. A great example of this is our relationship targeting product, where, basically we're looking at a campaign for a credit card company that gave you basically free gas as a reward. And what we realized is there were these interesting patterns in the location and IP data where certain devices were much more likely to convert. And what we realized what was happening is basically once one device converts, all the other devices around them that are maybe represent family, friends, these real-world social connections, they become much more likely to convert as well. So now this is basically a new data point, a new data set that we're able to construct that allows us to target ads based on these real-world probabilities and bring that information in for modeling for future campaigns. All right, well, thank you. I don't know if we have time for questions, but we'll be out front at the AdTheorent desk if anyone wants to talk more or ask questions. Should I? Quick questions, or are we all? Oh. Thank you.